Hello everyone, my name is Abhishek Jain and through this video I'm just gonna explain how can we set up a Scikit-Learn Python library for machine learning algorithms. And once we just set up the library on our window machine, then we're gonna see how we can build a machine learning model for one of the classification algorithm known as a K-neighbor for a packaged iris data set. So in Scikit-Learn, there are a lot of data sets which comes inbuilt which we can utilize to make our understanding how the Scikit-Learn works. So let's quickly jump into the demo part and see how we can first set up, the Scikit-Learn library. And it is very straightforward, like we install other Python modules. So put install, if I use dash u and if I just put scikit learn, okay, so what it's gonna do is it's gonna just uninstall if it is already installed. If it is not, then it is going to install it, right? Since it is already installed for me, so that's the reason we are seeing requirement already exists there. But for you, it is going to install a lot of the package, lot of the modules or the packages on which is uh, dependent upon, right? So few of them like NumPy, SciPy, the job lib. So those are few, you can easily get that on, if you just go to the Scikit-Learn library, Scikit-Learn website, you can easily find that out. So since it has already been installed on my machine, and if I just want to verify the version of it, so I have to just import sklearn. Okay. In the meantime, what I can do is I can just quickly go to the website. Just open this up. So since it has already been imported, I can just quickly put the version. It's going to give me, okay, it's 0.21.3. This should be the latest one. So let's quickly check scikit learn to see which version it has. It should be 0.2.13, the latest one. Yes, it is. So we are already set that up. Okay, so while running this command, if you face any issue, please feel free to put that in the comment section. I would be more than happy to help you on that if you face any issue. Now, since the sklearn library has been installed correctly, what we can do is I can quickly walk you through the location where it is going to install on Windows machine. Just go to the user, whatever the user you are logged in with, then go to the update and local, then programs. Okay, then you can come down here in a Python 3.6, go to lib, then site packages. Okay, from here you will see one folder named sklearn. Okay, so you can see sklearn. There is a bunch of folders which you're gonna see, and there is one folder named datasets where you can see the data folder and you have a lot of data. So what now we gonna see is we are going to just take this iris data set and we're gonna build a small machine model by using one classification algorithm known as K-neighbor. And there are many more algorithms which you can read through on the Google or whatever the way you like understand the new concept, right? But definitely I will also try to come up with the new videos through which I can explain what all algorithms are there and what all things you can do with that. Okay. So the very first thing which you have to do is you have to import the data set. Okay, so since I mentioned that it is inside sklearn module, you have dataset folder. Okay, inside that, okay, this one and data sets. Yes, it's fine. Just sets. Why it's happening for me? Okay, and scalar data set. What I want is I want iris data set, so I have to get this load iris. Okay. Now the next thing which we want to do is we need to create the arrays data object. So for that, what we can do is row arrays, and then we can call this. So it is gonna just become arrays data object. And if we want to really see what all options we have for this object, we can quickly check with the command. Let me just save it quickly, and if I just save this inside, save, Scikit-Learn, create, SKlearn, introduction. If I run it, okay, so let's see what all the methods or the option we have for this particular data set. See, so we have these, like we have data, features name, file name, target, and target names, right? So first we're gonna see what kind of data we have. Okay, so if I just put print values data, and I can just put this in capital X, iris data. Okay. The next thing which I'm going to show is iris dot target. Okay, and this I'm just going to assign to y equals to iris target. And let's see. So sorry for that. I was thinking I'm just working on the Linux environment. So if I just save it and run it, let's see what we're gonna get. So iris underscore data is not defined. I made some mistake. Okay, I chose some push dot. I save it and run it again. Okay. So we are showing a squeeze line 150. It means we have a 150 sample data. Then this one is the corresponding value. So in iris data sets we have let me just bring more thing which we can print it out here. We can print out the feature name as feature names. That is going to tell us. Along with that, what we can do is we can take out the X shape, which is going to be the shape of our data set for X, which are actually our feature, or we can say label, or we can say input, whereas Y is the corresponding value of that data. So if I just save it and just run it, let's see what we can get. So whatever the data sets we have, right, we can always load that data object, and we can just take out the data, simply feature name, through which we can see that we have sepal length, sepal width, petal length, and the petal width, right? So iris data set is basically a flower where we have these four attributes. We have sepal length, sepal width, petal length, and a petal width. What you can do is you can search for the iris on Google, and you can see the images of iris flower, right? So if I do that, so if I search for iris flower, see what we get. So this is what we have. We have these four, like width and length of sepal and petal, right? So now what we're gonna do is in machine learning, whenever you have your data sets created, since this is already a prepared data set, so we don't need to do it. But in machine learning, the major challenge which we have is to collect the data, to clean the data, and to convert into the form where your model can understand. But that is not in the scope of this particular video. So since we have everything done, so what we can do now, let me just comment out all these print statement, because we don't need any longer. What we need now is, so in machine learning what we have to do is, whatever the total samples we have to just distribute or divide into the train data and the test data, right? So train data means on which we are going to just train our model, and once it gets trained, then we are going to predict the value on the test data, which we can verify how much accurate our model is, right? So now in SKlearn, so don't worry about all these things, because the moment you will start using that for understanding more algorithm, all this stuff, you will get to know what all options do we have, right? So what I'm gonna do is I'm just gonna use a model selection here, and inside the model selection we have class train test underscore is correct. Yes, and correct. Okay. Now what we can do, we have a x and y. There is a very proper reason why do we have a capital X and small y. I don't want to get into that. Capital X is basically it's multi-dimensional stuff. We've always put in a capital letter. It's multi-dimensional vector or the array. Small is a single dimensional, right? Now what we can do is we can just create our train data. Okay. Similarly, we can create a text of x. Now we can create a string underscore y, and we can create string underscore y. And what why I did that? So if I just do that train test underscore split the same model, then object, and if I just pass my x input and y, what it's gonna do is it's gonna return me a full the different set of data, right? The first one is, and by default it's gonna put the train data at 75%, the 75% of total data into the train x, and remaining 25% in the test x. Similarly for the responses, right? And there is one attribute which I can utilize as test underscore size, and I can just give whatever the value I want to give. So let's say here you have to give 0.2. It means 20% of your data is going to be a test and 80% is data going to be your trained data, right? So, and there are a lot of attributes, so we should not be worried about that for now. Now what we can do is I can again print, so this time what I'm going to do is I'm not going to print, the complete data, rather I will just do the shape. And similarly, if I just copy this and just convert this into text, and if I just copy both these lines and just let me choose y. Okay, so we know that we were having 150. Oh, I was saying that I am in Linux, so I'm completely obsessed with that. So what I'm gonna say is we were having where we were having the 150 rows and the 4 columns in input, and 150 150 rows with the 1 column. That's the reason we're gonna see anything. So test underscore y is not defined. Let's quickly fix that. Okay, right, so I have to change this to test, save it, run it. This time what we're gonna see is if we just take the 150, 80% of 150, that is gonna be 120, so that is fine. So this is my input now, on which I'm just gonna train my model. Then we have this 20% of data on which we will be predicting, and we will try to predict the data and see how much accurate it is, right? So now the data has been split up, so we are done, but in real time, that's the major challenge where you have to prepare the data. Now the next thing is what we can do is, now as I mentioned earlier, before starting this video in the beginning, that we are going to use a KNeighbor, which is a classification algorithm. Okay, so sklearn dot, what I'm going to do is neighbors, if I'm correct. Okay, and I'm just gonna import keyword. Let's see. Okay, I think. Oops. Again, I'm just making a same mistake. Keywords. Classifier. Okay, and then let's just KNN, so that I should not be required to type complete name. Now what we can do is I'm just going to define as KNN equals to. So this is the very standard thing in if you just want to create any machine model. First you have to import that, then you have to initialize it. While initializing that, what you can do is let me just import this now. I can directly just so that my code will be more readable. So what I'm doing is I'm just creating a KNN object here, okay, and I'm just gonna initialize. Okay, so let's see. Right now I'm not making any changes, but there is, the n underscore neighbor attribute through which you can just see how much, the neighbor values, how much neighbor should have that particular, let's say if you are going to do five, then five values should be close to that. So I'm not gonna worry about that for now, but you can always control that, and that you will get to know when you will understand the K-neighbor. The next thing is what we have to do is whenever you just create the object, then you have to fit the train data. So our train data is what I'm going to do is inside this I have this fit, and this is a very standard way. Initialize your algorithm and create an object and fit, and in fit you have to give your train data. So my train data is train x, and the second one is my train underscore y. So this is what my predicted value. So you have to give input and corresponding output, right? Once that's get done, what you have to do is now you can predict it, right? So on which value I want to predict, right? So I want to predict a y, and then what I'm gonna do is same thing, KNN object. Okay, but this time what I'm gonna do is I have to pass input values which we have saved on which our model is not yet trained, and whatever the output is gonna create based on the whatever the learning model has is it is going to predict based on that, right? So once that's get done, what we can do is we have to import another module from SKlearn that would done the job for us, which will tell me, how much accurate, I think we have matrix, okay, and then what we can do with this matrix is uh, matrix, okay. Let me just print so that it will make more sense. First key model predicted accuracy, and I'm not gonna use astro for now. And if I just format it, and if I just pass the value, so in matrix, you don't need to worry about all these stuff. What I'm using it, you can just always learn all these stuff, and maybe I can just so now we in matrix we have accuracy score where we have to give a test underscore y, which is the remaining value, so which is the actual and the correct value which we have saved when we split it up, and now we have to compare this with whatever the values we have predicted, and we have predicted this y predict, right? So what it's gonna do is it's just gonna tell us the percentage. I mean, how much accurate, whatever the test value we saved it at the input level, and how it is, correctly, correctly, predicting the value. So if I just run it, hopefully I didn't make any syntax mistake, and if that's fine, then we should be able to find that out. Text underscore x is not defined. Why? Let me do, it's capital X, and I just use small x. Okay, if I save it. So but for now, if you just realize that this KNeighborsClassifier object is not tolerable, make a mistake, object dot update KNeighborsClassifier classifier. Okay, did I make a mistake here? Made a mistake. I think I have to define this. I'm not sure. Maybe I have to make this new word equals to 5. That happens. Canon object, canon object means why was saying object is callable classifier. Alright. Key neighbors. Why predict? Why predict? Why predict? Check. Oh, yeah. So here, I, oops, I have to use, I just made a small mistake here. I have to call this predict, right? I just fit that, but I didn't predict it, and that's the reason we were getting that error. So if I run this, then we should be able to get that. Okay, now KNN model predicted accuracy 1. It means that everything has been, you know, predicted correctly. It's 100%, right? I don't know, but luckily, if I just make it 4, let's see what's gonna happen this time. But I don't think so that was needed, where I just give that attribute. If I just remove, just see it this time it is, if you multiply with this accuracy, it is 93%. You know, if I just remove that, I was pretty sure that if I'm not gonna give this attribute, then it is going to just consider the default one. It's 100%, right? So I think it looks like the default value for this particular model is 5, and we just see we have achieved 100%. That is really awesome, right? Now what you can do is you can create this model, create an object, put it somewhere, and there is a job lib, I think, in sklearn, through which you can create, and you can create the object. But earlier I used to create it by using a pickle. You can use whatever the way you want it, but job lib seems to be pretty much simpler and easy to use it. So that's it from my side for this particular video. And if you have any feedback or suggestion in which you want to incorporate, which you want me to implement in my future videos, then please feel free to put that in the comment section. I would love to incorporate that in my upcoming videos. And thanks for watching this. And if you really like this video, then please give me a thumbs up. And if you haven't subscribed it so far, please subscribe for my channel. And also one more request I have for you guys: if you really feel this, if these videos can help your friends or your group, please feel free to share this video with your friends and your groups. And that's it from my side for this particular video. If you want me to cover any specific topic, please feel free to put that topic name in the comment section. I would love to come up with the videos on the topic which you choose and which you just gave to me. Thanks for watching once again, and as always, stay healthy and keep learning.